and thanks for listening to another episode of DIV Innovators. Today, I'm speaking with Jonathan DiMattei, founder and CEO of Lothric Labs. Jonathan, thanks for joining.
Thanks for having me, David. Appreciate it.
Yeah, this will be awesome. So first of all, we'll start off with, you got a very cool background, interesting journey to now be supporting the defense industrial base. First of all, thank you for serving, and you were in the Army. How'd you get there? And then how did you move from there?
Do appreciate it. Shortly after 9/11 occurred, I was going from gym to philosophy class. And as I walked in my classroom, I actually saw live footage of the second plane hitting. And at that point in time, I made a stern decision that I was going to join the military. I actually did delayed entry. So on my 17th birthday, I fully enlisted in the military on delayed entry program. So my entire senior year of high school, I was actually signed up for the U.S. Army. Got the honor to go to all the assemblies and, kind of be made an example of that, early age joining of the military. And I took the ASVAB at the time. It was top score of 89. I got an 88. Liaison opened the book and said, "We have 212 jobs. You may pick one." I ended up becoming a 96 Bravo intelligence analyst. So through that came some top secret security clearance and training. And that's really where my inclination for technology came from.
Okay, so how long did you serve for?
4 years.
4 years. And then you decided to jump ship. What did that look like for you?
Yeah, just honorable discharge and benefits, and felt like I served my time. I was held stateside, so no deployments for me. I was stationed in Fort Huachuca, Arizona for most of it. Got a chance to work with OPCOM, which is Operational Test Command for new technologies and weapons. I got to see some pretty cool stuff while I was in. And then prior to the military, I was in the automotive industry. So aftermarket electronics. First job was Circuit City, doing alarm systems, car stereos, AV entertainment, home theater entertainment as well. So really got forcefully back into that industry after exiting the military and worked for a multitude of custom shops. I ended up doing in Tampa, Florida. I worked for a place called Sensuous Sound Systems, for example, that did $1 million and up dedicated home theaters. I ran their whole car audio department. So we got to work on exotics and do some really fancy Florida, Miami Vice type of cars, which is really cool. And then work my way through that industry.
What's the nicest car you worked on?
Nicest car? That's I got to work on some classics too. 512M Maranello, a Testarossa. That's super rare. Got to work on a McLaren P1. Got to work on probably most namingly and probably one of the most rare is Zinger's C2. That's a $2 million mostly 3D printed hypercar. I got to work on the development of the push to start system for that. That's probably number one.
Oh, that's cool.
And they're actually owned by Divergent 3D, which is a massive 3D printer manufacturer and technology company. So they're a subsidiary, and basically their weekend toys that they make are $2 million hypercars that beat the McLaren Senna. So that's pretty cool.
That is pretty cool. Okay, so you're doing that. And then what's next?
I worked through that industry for quite a while, ended up becoming an IASCA judge. That's the International Auto Sound Challenge Association. So when you go down to Florida, Palm Beach area, Tampa, and you run your vehicle, your very classy show vehicle through competition. I was actually a judge for that organization. So I would come out in that white lab coat and clipboard and judge folks on their installation quality and also sound quality. So it just became a real reference in that industry for what it means to, create a good entertainment system. And then based on staying in that industry for a while, ended up working for an automotive electronics manufacturer for about 6 years. That was Vase Technology, and that's what led up to opening Lothric Labs. So I worked directly for a tier one supplier for prototypes and parts for Toyota, and then that's what segued me into that Zinger project.
And so what was the use case? You're like, this is a business, let's go.
I've been doing 3D printing for 10 years, 2015. So you got to think, and this is kind of cool that we're talking about this on a professional platform, especially, with the defense audience. 3D printing in general, stereolithography has been around since 1978. Standard 3D printing, FDM, what we refer to, has been around since the mid to late 80s, but mostly in professional and private sector and government. NASA had a 3D printer on their early spacecraft to develop things like working ratchet and tools, which we're actually redeveloping as we speak. So I can kind of show you some of that stuff. But as far as available to consumers on your desk, we really started seeing 3D printers show up to our shores in about late 2014, early 2015. I was one of the first American consumers to have a desktop 3D printer. I mean, before people really knew what they were, obviously you have large companies like 3D Systems and Stratasys, and they've been catering to that private sector and government industries. I had one of the first 3D printers that were available to consumers, and I had a store in Tampa, Florida, making Pokemon and fidget spinners and pop culture stuff. And you come with your kids, buy a few, toy items, and I kind of pick your brain to say, what's your favorite Marvel movie or whatever, and we'd make your favorite artifact from your favorite movie. And I've been doing that for years. So I have a ton, thousands and thousands of hours in desktop 3D printing. And just as time goes on, that's a hobby of mine that just never stopped. I ended up replacing my income in early days doing that. And now we pushed into, full professional workspace 3D printing. So we still do promotional items like coasters and keychains and little fancy stuff like that. But we really move into more exotic materials now, like real carbon fiber, castable wax for jewelry. We do ceramic. We do medical modeling printing, nothing biocompatible. We do like, human vertebrae for chiropractors. We do actively working on carbon fiber tools for the experimental aircraft industry. So if you build your own airplane that's non-regulated, we offer carbon fiber replacement parts for them. So this is just a hobby gone crazy, and you work at I was handling the prototyping for that electronics manufacturer. So, got to work at much more of a high capacity and requirement in terms of switching from pop culture stuff over to things that required aerospace tolerances. And that just really upped my skill set to the point where I felt like this was a viable business. And lo and behold, we've been open 10 short months. I opened to the public on January 2nd. I worked on the intellectual property of Lothric Labs for a year prior. And we now have over 15 vendors. We're just naming one. We're the U.S. strategic partner for Ultimaker. There's only 7 of us. We have over 50 active clients already. So if you're out there watching this and you're wondering if 3D printing is a good business, there's your answer.
That is great. And so on the defense side, where have you found interest right now as you're moving forward?
Tons. I mean, that's a good segue from the brand I just mentioned. So Ultimaker namingly is going to be one of the largest. The Ultimaker for desktop 3D printing, they are the only UL listed 3D printer available on the market. They're the only one adopted and used currently by the US Army. And now we just launched a secure line, which is engineering grade 3D printers that are totally turnkey. They all have RFID on them. So when you put a specific roll of material in, it matches that material. It makes it very novice proof. And they're secure versions of them. So they don't even have internet connection or camera capability within them. And just for an example, we just got a quote request from Canadian Coast Guard for one of them. So this is a printer that is specifically for the defense industry. Ultimaker has all the paperwork to back it up. So that's something that we're going to be moving into defense companies individually, and then also possibly some publicly accessible SCIF spaces, which I just walked through 2 of them actually.
What would you be doing in those?
Provide a couple of things. So a company like myself personally would be utilizing small desk space in a publicly accessible SCIF to get on CWIN and start doing, contract bidding. And then that's a really good way to get a small company into compliance. And then more importantly, actually providing them with 3D printers. You walk through a publicly accessible space like that, they have a government regulated paper shredder. They have, all these community type of assets to be used. And the pitch right now is to get these secure 3D printers in there, because essentially a SCIF client could walk in there, create a prototype in total confidence, put it into a Pelican case and walk out without it ever being seen.
So from a technology standpoint on 3D printers, don't you need to be connected to the internet to be able to download plans or ideas? Like how do you run around the classification with that?
On a communal basis, yes. But if you think about it, a defense company that's doing their own internal engineering, they would create that part in a CAD system totally offline, export the file to a secure style USB or storage device, and it can be inputted right into the machine with never being connected to the internet. Obviously, if we are doing transfer of data, we're doing that over a secure space like Microsoft GCC High or a regulated pipeline or cloud storage service. But yeah, you could absolutely create a prototype in total confidence, stick it in the machine and print it.
Have you run into problems with, you got all the compliance coming on, so, CUI material, if you will, printers, especially ones that are doing that, might be more challenging. How does that interact with, the compliance requirements and security in general?
And that's really the one brand I know of that is in line with compliance for placement for, direct government applications and also third parties is Ultimaker. I don't know anyone else.
The special printer that is offline and you can do it.
The printer is compliant. Exactly. That's going to be the secure series from Ultimaker. So it's like they have different sizes and different capabilities. They even have one called the Factor 4, which is that big fancy one on our homepage at lothriclabs.com. That's a secure printer that does aerospace grade engineering materials and tolerances, which is crazy. And actually, we have a special part that was made on that Factor 4 machine. Like I said, aerospace grade materials as well as tolerances. What's really crazy about this, for example, so this machine starts at about 20K. It is secure version available. What you're looking at right now is super unique in terms of a 3D printed part. Number one, I mean, you can see the overall quality of it. You don't see any visible top lines or anything like that. But what's really noticeable about this part, this was created on the Ultimaker Factor 4 PETCF. So this is PET plastic is similar to what would be used in an injection mold. So thermoplastic quality. So it's chemical resistant. It's impact resistant. It's super strong. What's really noticeable about this part though is this red piece right here. This is PEEK. So this is polyethylene ketone. It's super strong. It's compliant up to 400 Celsius. So it's insanely heat resistant and impact resistant. And if you notice, this wasn't assembled. The printer printed this inside of this body in one pass. So really, really noticeable qualities coming out of that company. And to answer your question, yes, you could have it to where you could totally print something without a data trail.
Very cool. So come from the automotive world. What's been interesting about that difference when you compare it to working with defense clientele?
Just quality of work, clientele, relationships. The jobs we're working on are super rewarding. Not that it's not rewarding to modify and upgrade a car to your dreams content, but I mean, when we start getting into, defense and compliance, we're talking about things that are viable in helping change the world to be a better place. I mean, that's what the space program is really about, isn't it?
Yeah, absolutely. And do you find, a lot of folks find it challenging to, get the relationships, build that? Are there a lot of folks doing what you're doing, or, the primes doing this internally, or are you finding a unique niche where you're able to?
Great question, David. So very unique niche. So you have, like I said, companies that have been catering to the private sector for 2 decades, such as 3D Systems, Stratasys, DMG Mori, EOS, all the big boys. These guys make, $500,000, $1 million and up 3D printers. And that's always been, it's like the Lockheed Martin factor, to be able to afford to build your own SCIF, you have to be a large entity to be able to even get into those compliant type of areas. For the longest time, most professional 3D printing was provided by those larger companies directly to larger clients like Lockheed and United Airlines and things like that. And then, as time went on from the launch of desktop available 3D printers to consumers, now you have really, really good quality 3D printers that are available at, reasonable cost. And typically what you see, for example, if you look up 3D printing on Google Maps, you see a couple of guys and girls with, a nice like Creality K2 or a Bamboo Lab or something that's very good. It's not a Ultimaker Factor 4, obviously, but they boast themselves as a 3D printing service. And typically what you see is that person's house and a picture of their single printer that they have available, and they're doing it as a very, very professional hobby. Or you go up to, full-blown Ultimaker Direct or things like that. There's not a lot of services like ours that are sitting right in the middle in a sweet spot. And like you said, it's a very niche thing. And we offer everything in the professional 3D space, from design services to reverse engineering with 3D scanning. We will do print services. So we'll actually make you carbon fiber parts. We'll sell you the printer. We'll offer you material. We do education and training. We're the US partner for Voxel Dance, which is a very competitive data preparation software that's used to optimize things to be 3D printed at the level that a company like Canopy or Augustus would use. So yeah, no, I mean, not many people in the level in this space like we are.
You find in, your, let's say, small businesses, small, medium, they're 50-person less aerospace companies. Are they looking more to buy the printer, or they just want the part?
Both. So some have come in for consultation and what we call DFAM. That's a very popular acronym right now, design for additive manufacturing. So just on a consultation standpoint, a small aerospace company adopts their own 3D printer, they'll often contact us for consultation as to how to guide them in terms of optimizing their model, because the way things are heat molded, vacuum formed, injection molded, none of that has the same geometries as what a 3D printer would require. You're working with differences in, how you have to battle gravity and thermal expansion and all the things that occur inside of, and there's more than 20 different types of 3D printers in terms of there's ones that use liquid and UV light. There's ones that actually deposit melted material. There's all kinds of different processes. Each one of those types of machines comes with a different requirement in terms of how we need to make the 3D model to get it to print correctly. So just on a service basis, we do that quite a bit. Also, our software is very likable to smaller companies because we offer very, very competitive price point. So similar softwares that we use for this high-level 3D printing are annual basis only. They're about $20K a year per seat. We offer perpetual licenses and training. So there's a lot of ROI to buying our software as opposed to our competitors. And then, we're also seeing smaller companies going through rapid expansion right now and wanting to get into their own prototyping. I won't name which, but I'm working with an aerospace company currently that just went through a 22 employee expansion. They just moved into a new facility. They have a whole empty room with an engineer and his desk, and they're looking to get into a whole bunch of machines, 3D printers, scanners, software, you name it. So like I said, we either will teach folks to fish or provide them with fish. Either way.
So as I find this interesting, so a lot of manufacturing, you've got your piece of metal, for example, and it's got to go through all this testing. Then you have, more of the fiber side or the 3D printing. How do you get it to where they know that the tolerances are the same? Because, imagine the type of material you use when you make it. How do you get certified? Or yes, that is, aero certified, if you will. I don't know what the proper term for that is, but is that a challenge or is that actually pretty straightforward?
That comes from a couple of things. And obviously, like you have again, we won't name who, but you have companies doing things that are under such tight tolerances that you are undergoing multiple processes to achieve the part. So if you think about it, that's a perfect question. I mean, you're forming metal or milling metal to be within a certain tolerance from the part that it's touching. And you achieve that with a very high quality material, CNC, the G code that does all that, and that carving of that material. 3D printing is the total opposite. And now we're producing a part that could have swelling or expansion going on. You have a resin that's activating to a UV light. There could be thermal expansion or contraction going on. And now you're going to have a part that's slightly a different size. Beyond that, you have a part that's larger than it needs to be. And now you're putting it into a sintering oven or an annealing process to basically get rid of all of those unwanted materials. So if you're doing, a lot of like ceramic, for example, ceramic will have polymer infused in it for binding purposes. It uses the plastic as a glue. But when you put it into a sintering oven, it's going to extract out all of that plastic. And now you're left with a very slightly smaller part. So something that's really cool is that, our experience as a company working with over 350 different materials over time, all of these different processes. Beyond that, our software will actually help on a simulation standpoint and tell us how much larger we need to make the part to compensate for that shrinkage. Just one example of many, but there are absolutely companies out there achieving it. And typically to get in that aerospace tolerance, obviously this is an exception. This is a big bulky part, $20,000 printer. If you're talking about metal and aerospace tolerances or ceramic, you're talking about probably $250,000 and up machines and software to go with it to guarantee that result.
That's interesting. So what's the biggest misconception about what's possible with 3D printing?
Right now, from the consumer market, realistically, what we as the public know to be 3D printing has been everything you see on Facebook and Amazon and just pop culture stuff and toys. Or if you get into a professional space, for example, the 5 or 6 years prior to opening this business, the consensus, the common feedback has always been, well, 3D printing, other than the toys, 3D printing is good for a first iteration prototype, just so you can hold it in your hand and look at it and make sure it's good. But then you still need to go to conventional production. That is the biggest misconception. Those days are over. There are massive amounts of companies making final end use parts in the shoe industry, in the medical industry, in the automotive industry, you name it. Ferrari's new F80 suspension is entirely 3D printed. So we are now having end use cases for all types of 3D printing processes. And that's still currently a big misconception.
Yeah. And what was it sounds like it happened pretty quick. Was it tough to break into the defense industrial base, kind of the defense side, or was that pretty smooth?
To fellow business owners, colleagues, coworkers, I've always described my pathway as being fearless and relentless and totally unbiased. When I opened this company, I would network with you no matter what walk of life, real estate, defense, no matter what. Went to every viable networking event I could find. And honestly, I think where our capability comes in is from my extensive amount of experience and versus reading a brochure. And I say we're a team of 5 now. So I do have a few territory managers. I have a resident engineer as well. I'm also Autodesk certified as an engineer. We live and breathe this stuff. So the elevator speech is very natural. So it's really just getting in front of the right spaces. I was going to ribbon cuttings and grand openings through our Chamber of Commerce, which has been a really good exposure. And then where we met you as well, though. You're World Trade Center member also, right?
Yes.
So yeah, just a bit of advice. I mean, World Trade Center Denver has been an excellent pathway for the right type of client to sit in front of, to get yourself exposed, going to all the WTC events. We're getting in front of United Airlines, Lockheed Martin, defense companies, aerospace companies. So that's just a really quality, I like to call it like a global chamber of commerce, right? They just have really, really quality pathways to get in front of the right clients.
I mean, it's cool that a company your size can be making parts and selling to these larger companies. I mean, that's not super
Indeed
common.
Not at all.
So in the defense side, they've got the compliance requirement for CMMC. I think you guys are good or well underway. What was the biggest thing that caught you off guard with that?
I mean, that's like anything else. I mean, you go and traverse a territory or a part of life that you've never been through, and you kind of navigate things as best as possible. And that's a perfect question. I mean, I think that's why it's really crucial to have companies like yourself to guide smaller companies like mine through that pathway. I mean, realistically, you could wake up in the morning and say, I'm going to go get defense contracts. And it's not as easy as it is said getting out of bed. So I think it's very important and crucial to have companies like yourself to guide, guys like me through that process. And I think the other really cool thing is, I had an experience to walk through 2 public SCIFs. And I think that's the wave of the future, being able to access a single desk or a 4-person office on, government compliant internet connection and be able to start getting defense contracts and even on a modular basis, temporarily be in compliance while you're in that area. That's going to get, smaller guys like myself in that workspace.
Yeah. Who'd you use for that? I mean, I've got, some friends who got another company, but was that owned by like a large prime or who was it?
I walked through Westway LLC. So that's over in Aurora. And that's in the old ADT building. And these are new projects. So, and forgive my statement on this. I believe this was something that was passed recently in the sense of being able to produce a publicly accessible SCIF space, because realistically, that was all, private company oriented. The entire facility would have to be built by someone or financed by someone like Lockheed Martin. Whereas now you have Westway LLC, and then the other one was Nooks. Nooks. So that one was down in Colorado Springs. They're both very impressive. Awesome facility, security desk, ID badge and check-in. You got to bring your passport and all secure lockable areas, file safes, government compliant shredders and things like that. But I think it's really exciting for someone that's in my space to be able to get into the bidding arena without having to put the carrot before the horse, if that makes sense.
Yeah. I've had Sean Blackman, the co-founder of CEO of Nooks, on this before on our podcast. So,
okay, excellent.
Yeah. It seems like a really cool model.
Yeah, I got to do a walkthrough with Andy, and quite a facility. I recommend anybody that gets the opportunity to go down there. My avenue to be able to get a walkthrough with them was JLL. So just shout out the guys over there. And they were able to bring me into that space to just kind of educate me on what we have access to now.
Yes. definitely a neat capability to do things like this, where you can go in and don't have to spend a gazillion dollars, building out your own.
And that honestly, and that going back to your original question, that came from networking. Connor, my engineer, and I went to the State of Aerospace by BizNow. We got to listen to their panel discussion and learn that these SCIFs exist. I had no idea that they existed before that.
Are you holding your own clearances, or do you have someone else holding them for you?
In process. So we have applications in for FedRAMP and ITAR. And then I think we're going to get with you on CMMC. We don't have that complete yet.
Oh, perfect. What's the biggest bottleneck slowing down production you see in the 3D manufacturing space?
That could be lack of understanding of the process itself. So, if you think about it, you're a startup, you get a $15 million contract, you buy a big fancy $250,000 ceramic printer, and it's like, okay, well, now what? Where do we source the material from? What do we do? There's a lot of unknowns in the 3D printing arena. And that's where we come in first is for advice and consultation reasons. And it's like, hey, this is the type of material we need to be using. Here's the software that's going to optimize your workflow. Here's how to design a 3D model so that it's not going to be a disaster on your machine. So the big bottleneck in the very beginning is going to be, adapting to a brand new process that no one on your staff may be trained for. And I think that's, where we're really popular and, walking in the door. Obviously we come in later and say, okay, now we can provide you with all this hardware and material, but we really come in as a consultant first.
Do you find yourself getting locked down with, how quickly a customer may want you to iterate on something, or are they pretty clear and coming in with exact standards when they ask you to do something?
Yeah, that's all over the place. We work with aerospace companies. We work with experimental aviation parts companies. I work with guys that make and fabricate their own cabinets and own a small business, and they just want end caps for their little LED light bars. We do it all. I've worked with a well-renowned chiropractor making, bone-like human vertebrae that actually have like silicone-like ligaments that attach to all these things together. What's really cool is like I've worked with so many processes that we don't say no very often. So to properly answer that, it's all over the place. I mean, you might have a customer or a client, with a couple of day turnaround expectation. You might have ones that are more on a budgetary timeline that are less concerned about that. So realistically, it is pretty all over the place, but we usually turn around a first iteration prototype within a 2-week period. So if you contract us to do design, obviously if it's immensely complex, it would take more than that and be on a more of a milestone design basis. But most single small parts we could turn around in 2 weeks, hand you a working carbon fiber prototype, for example. And then based on that working, we would go to semi-production, small run production we do in-house. And then anything usually over 1,000 pieces, we'll work with one of our partners.
What do you think is the biggest, just for someone that's not super familiar with 3D printing, where is your biggest limitation in being able to design parts for aerospace? We'll use aerospace as the example, or defense in general, but where is it? Well, I'll just leave that open.
That's a great question. And I think it's one that, your company would help answer over time. I think it is compliance, the knowledge of how to expose yourself to the right clientele and actually literally getting your feet into these aerospace companies and defense companies, to at least shake some hands and, start building those relationships. That's going to be challenge number one. But realistically, being compliant enough to even have those 3D models shared with you. And that's the, the pathway we're well on our way with now. But, to someone who has no compliance whatsoever, has never talked to a company like yours, that's going to be a problem. They could totally know what they're doing, get in the door, go to the ribbon cutting, shake the hand of the CEO, say, okay, I'm going to 3D print you everything. And it's like, all right, now where's your compliance? What was cool in the very beginning is like, a couple of defense companies kind of nudged us, with their elbow and helped us along the way of the idea of, okay, we're okay with looking at these various products, but we at least want to see, compliance application on your roadmap. So some of them were a little bit softer than others, where a big company like Lockheed, if you don't have that, if you don't have that cert number, you're not getting that 3D model, period. So that could be a big challenge for guys like myself.
How about from a capability standpoint, like 3D printing has unique advantages over traditional manufacturing of parts. We'll use parts. Just real quickly, what are the advantages to it, but what are the disadvantages to 3D printing?
Massive advantages are going to be the most coined phrase in the entire industry, and that is rapid prototyping. It's literally that. So, typically on a high level standpoint, you would have to go through tooling. So if you think about it, if you have a composite or a plastic component, and let's just say an enclosure, that's what I specialize in, enclosures for PC boards and small components, to prototype that plastic before, when it was, we call it additive manufacturing. That's because you're literally depositing the material only needed and you're adding to it. Subtractive manufacturing is what we know before. You take a giant block and you cut everything away that you don't need. So you have massive amounts of material waste with those standard types of processes, and the ability to produce a part, get it in place, figure out what you need to change. If you own that 3D printer and you're not dealing with a contract manufacturer or a third-party service, you're doing that on a very rapid basis. And now, especially, you ask like where it started versus where it is now. To make I would say probably a 200 millimeter tall part when 3D printers first hit desktops in the consumer market, that was a 40 or 50 hour print. Now these machines are 5 to 7 times faster than that. So they are genuinely rapid, especially in the realm of plastics. SLA and, the resin-based ones can take a little bit longer, but they now are truly have caught up to the concept, in the sense that I can start a part and receive it before I leave here for the next day. So that's becoming a very quick way to figure out if this is going to be a viable component to the project. Some things that could slow you down, again, is the understanding of the process. Not a lot of conventional education. You are starting to see a ton more in college market. So School of Mines, a lot of specialty schools, Legacy Campus, Epic Campus, they're adopting 3D printing into their robotics program. So they're training, guys and girls at a much younger age now, which is great. So we're seeing, educate a more of a regulatory education about 3D printing, which is awesome. But most guys and girls, above that college age are, essentially in the dark in terms of, okay, we got this 3D printer. Now what do we do? So that could be a big problem. And the vast amount of materials that are available. There are thousands and thousands and thousands of different materials available. So it's like, okay, we have an engineering staff. We designed a part. We bought this 3D printer. What material do you make it out of? So that could be a big holdup in terms of, I've seen companies immensely frustrated with, okay, I spent $7,000 on this carbon fiber 3D printer. I bought this software for it. I bought this material for it, and I can't get it to make a part. Well, that's because, the settings need to be changed in your program, and we're using totally the wrong material for this type of application. So what you have to imagine is like thermoplastics, composites, things like that. They're not the same material. Everything in 3D printing is like. So it's ceramic-like material. It's got ceramic powder loaded into the resin, but it's also got photo activator and plastic and all kinds of other stuff you have to deal with to get it to 3D print. Same thing goes with these materials. When you really step up to a more professional standpoint, you could get into pellet 3D printing, which actually prints raw manufacturing materials. Now you're talking about the exact same, type of engineering qualities that would work in an older type of process. So just knowing what to use is totally a not educated thing. And again, that's where we come in.
Yeah, that's very cool. So where is Lothric Labs, Jonathan, going to be in 5 years? What's your vision, goal, and how is 3D printing going to change as you guys continue?
I'm just very blessed to say how I'll use the term rapid, how rapidly we're growing. Like I said, we were made U.S. strategic partner for Ultimaker. We actually just onboarded with a company called EOS. They're a German 3D printing manufacturer. We haven't even made the public announcement yet, so you're the first to hear this. So we're going to have a partnership with them for benchmarking capabilities to help assist them with their 3D printing processes. And we also have the capability to resell the machines. These guys, these are the 3D printers used by Beehive Industries to make their rocket enclosures. So you're talking about laser-based, very high-end 3D printers. So getting into much more of a professional market is directly on our horizon. We're starting to get into the, contract bidding arena. And then outside of the defense industry, I have a couple of plans for our company. So we're doing a ton with just engineering, consultation, hardware, but usually more printing services and consultation. In the future, we're going to be doing a high retail space similar to the Apple Store, where you'll walk in and be able to shop directly for Ultimaker printers. We're going to do a services brand. I have a whole nother intellectual property brand. Can't announce yet, but we're going to be doing similar to like a floating kiosk in the shopping mall. where you go in and get your hat embroidered. We're going to have these high-speed 4-color, multicolor 3D printers. You're going to be able to walk up to, somebody fresh out of college, bunch of 3D printers in the background, design what you want right in front of them, and pick that gift up the very next day. So we'll be doing that for consumers. And then one of the other avenues we're going to be working with, we actually provide we sell a 3D printer that's 1 cubic meter. So it's 1,000 by 1,000 millimeters. On a diagonal, it can print the entire front end of a car. It can print a Ferrari seat, and it's in one piece. So I'm working on a project where we're going to pull up with a box truck with this giant 3D printer in it, go to your facility, plug into your power, print the part, push it off the truck, and go back to our home base with no shipping involved. We're actually going to print it on site for the company.
Wow, that's cool. We've definitely got some great opportunity out there. It's cool to see that. Well, very good. Well, I think we're going to have to wrap this up, but I really appreciate your time. I'm glad our teams got to connect and, meet you. Thank you for sharing your wisdom. If folks want to get involved with 3D printing or contact you, how best would they do that?
So yeah, lothriclabs.com, LOTHRICLABS.com. So it's going to be our main website. You can always email us, info@lothriclabs.com. Look us up on Google Maps. You can give us a call at 720-303-1880. We're in the office from 9 to 5, Monday through Friday. So if you have any questions or concerns or just want to learn more about 3D printing, we literally have 3D printers starting at $299 all the way up to about $9 million. No exaggeration.
That's pretty cool. Well, this has been awesome, Jonathan. Thank you very much. And I look forward to seeing you around the block.
David, I really appreciate you having us, and we're going to stay in contact with RADICL much more often.
Awesome.